It's the second lesson of our unit on like the coordinate plane. So let's just start. So if you can see the screen, say yes in the chat to let me know. If you cannot see the screen, say no. Yes, okay, very good. Let's go to the slides. Lesson 2.2 of our unit. And we're going to be learning about equations of a line today and how to model real-life situations with linear equations. So let's go to the schedule. Of course, we're going to go over homework. So I think a lot of people have turned this in, so very good. I didn't get to grading that yet, but I will be in the next couple of days. Should have that graded. And then linear equations. And then that's basically a review of linear equations because most of you learned linear equations in Algebra 1 anyways. So this is just a little bit review. The main topic for today is the linear equations in the models, but it's not too hard. So, and then of course I'll provide some examples as well. So let's go over to the homework. Find an equation of a circle with the center -3, -1, and radius length of 5. So I'm gonna give you guys like a couple minutes to do this. Put your answers of the homework in the chat. This should not have been too easy, too hard. So it should have been a pretty easy question. So just put your answers in the chat and I'll walk you through this one. All right, so we have a couple of answers. That's good. So 3 answers, very good. So let's see here. And I think mostly they're correct. Find the equation of the circle with center at -3, -1. So what is the equation of the circle again? It is the x minus h squared plus y minus k squared is equal to r squared. So the center is going to be hk, and whereas xy is just a general point on the circle, and r squared, of course, is the radius squared. So we're literally just given all the information we need, so we can just plug that in. Since -3 is h, you can see that it's x plus 3 squared plus y plus 1 squared. The radius of length 5, great. That's just going to be 5 squared, 25. So that's the equation of a circle right there. It was not too hard. Let's try a little bit, one with a little bit more elaboration. You had to use like the distance formula for this one. So I'll give you another couple minutes to do this. Put your answers in the chat and I'll walk you through it. All right, so let's look at this. Okay, so find the equation of a circle with center 9, 1 and passes through negative 1, 2. So we know that center is HK, right? HK. That is going to be our center. And we can just combine that with like the equation. So let me write it again here. Let's not. It's x minus h. So we know the center, which is 9, 1. So let's just write that down. X minus 9 squared plus y minus 1 squared. But we still need r squared. So what we need to do is we need to find r. And basically what we can do is we can use the distance formula to find r. Because we know that our center, for example, is going to be at 9, 1, around here. And it passes through -1, 2, which is around here. So our circle is a pretty big circle. It's going to come all the way there, right? It's going to pass through that point. Well, no. What am I thinking? That is, dang it. Sorry about that. Okay, let's try that again. We know 9, 1 is the center, and it's going to pass through -1, 2. So this is the circle. Made a mistake earlier. 9, 1 is the center. Okay, so now we can solve it. This is the radius. Because we know that the center and to a point, like an arbitrary point in the circle, is always going to be a constant radius. So the distance between these 2 points will just be the radius of the circle. So now we can just solve using the distance formula. So the distance formula is very similar to the Pythagorean theorem. So basically, we take the difference in the x coordinates, right, which is going to be 9 minus -1, 10 squared. Okay, then we add 2 minus 1. Okay, it's gonna be 1 squared, and then it's gonna be 100 plus 1, and we take the square root of that to get the radius. However, we need to notice that we don't actually need to use the square root of 101 here, because our equation only needs r squared. So in this case, it's just 101. So that's how we do it. Are there any questions about this? If there are no questions, then I'll just continue with this one. So this one, people might be having a little bit trouble with because it's the equation of the bottom half of a circle. So let's see if you remember how to do that. So I'll give you a few moments to do that, and then I'll walk you through it. All right, so I see we have a couple of answers. So very good. Yes, very good. So this is exactly, I think, how it should be. A half circle from that. So before we even try to solve this problem, let's just first try to find the equation of the half circle for the bottom half of the circle. So I see William answered, right? So William, could you help me try to find the bottom half of the circle? What is the equation of the bottom half of the circle? William, could you volunteer?
So since we're finding the bottom half, y has to be less than or equal to k.
Very good.
So the equation will be y y minus k to the power 2 is equal to r squared minus x minus h to the power 2, and I just plugged all the values in, so it becomes y plus 5 to the power 2 equals 14 minus x minus 1 to the power 2. So, and that is equal to negative y plus 5 equals to the square root of 14 minus x minus 1 to the power 2, and that is equal to y plus 5 is equal to a negative 14. I mean the negative square root of 14 minus x minus 1 to the power 2, and that is equal to y equals negative 5 minus the square root of 14 minus x minus 1 to the power 2.
Okay, y is equal to what again?
Negative 5 minus the square root of 14 minus in parentheses x minus 1 to the power 2.
Very good. So because y is less than or equal to k, that is the subtle point here that you must understand. This inequality, meaning because y is less than or equal to k, y minus k must be negative or 0, but we don't care about 0. We just care about the negative. Because it is less than or equal to 0, the absolute value is going to be negative x, and therefore negative the quantity of y plus 5, meaning negative y minus 5 is equal to the square root of blah, blah, blah. And you get this, therefore, okay. So this is the key point. Whenever you're solving for half a circle, always remember something is less than something, right? And because you have to use the absolute value. Because you see here, this this, this is a function. This is a function. The importance of the absolute value is to change it into a function. Because a circle, that's not a function. Remember the vertical line test, that's not a function. Because one x value can correspond to two y values. Therefore, it is not a function. So the point of the absolute value is to make this half circle into a function because the bottom half of the circle is going to be a function. So that's the important part. So now let's go over to another circle example. So this one I forgot to include in the homework, but it's basically pretty similar. I just want you guys to be exposed to this kind of problem. It's quite common. So find the radius and center of a circle from the equation x squared plus y squared minus 8x plus 10y is equal to negative 25. So I'm going to ask someone to help me again. Who wants to volunteer again? Do you have any volunteers that would like to solve this problem? How about Edward? Could you help me solve this problem? You can type in the chat your answers or something else. If not, how about Kaylee then? Kaylee, will you help?
Okay.
Okay, so before you even start solving this problem, you gotta figure out what you need to do first. How do you find the radius and center from this little piece of junk here? We don't know, right? We don't know because it's not an equation in the circle, right? So your first step is going to make this into an equation of a circle. So how would we do this?
We
I'm just going to group the x's together and the y togethers. And as you can see here, now it looks a little bit better. So what can we do? Let me put the equation in the circle for reference. Okay, for reference is equal to r squared. So what we need to do is we need to make something like this. We need a square, right? And Kaylee, you know how to complete a square, right? So the important part is this to know how to complete a square. That is the key point of this example. So complete the square.
uh
Did you forget how to complete a square?
kinda.
Okay, that's fine. So you know the squares, right? X squared minus 8x. We need to add something, this little thing. You need to add something. And that's going to make it into x minus something squared, right? So essentially, what is a square? So we need to add 16 to this. We need to add 16. X squared minus 8x plus 16. Why is this? Because this term is always going to be the b term divided by 2 squared. You can notice this. 16 is equal to 8 divided by 2 squared. Right? We prove the quadratic formula with this. And similarly, the 10. Kaylee, what is 10 divided by 2
5,
squared?
25.
Yes. So we're going to add 25, right? That's the trick. Because this is always going to be this divided by 2 squared. That's how we figured that out. That's all perfect squares. All perfect squares are going to have that quality. So we're done, right? We added them. Great. But we're not done because we added all of this to this side, but now the equation is unbalanced. If we have to add 16 to one side, we have to add 16 to the other side. And similarly, if we add 25 to one side, we have to add a 25 to the other side. So let's just do that. And very conveniently, the 25s cancel out. So you're left with x minus 4 squared plus y plus 25 squared is equal to 16. And we know comparing to this equation here, r is going to be 4. And the
Plus-
center, yes?
Plus 25 squared?
Oh, shoot. Sorry about that. Plus 5 squared. It's because it's adding whatever this square root is. See, if the last term is 16, it's going to be minus 4 squared. If the last number is 25, it's going to be plus 5 squared.
Okay.
Notice the sign here too. So if you're still having some trouble with completing the squares, you definitely need to review that. So I think we covered it in unit 1 of this course. We also covered it in algebra 1. So, but mainly in unit 1 of advanced algebra, I think it was lesson 2 or lesson 3. So you can go back. It's on the Google Classroom. You can go to the recording and you can review. I think I explained it a little bit better back there, but right now I'm just not going to explain that much because we are learning about different stuff right now. But if you do need help with completing the square, you can go to the recording on the Google Classroom, or you can just go on online, like YouTube. I'll teach you enough. Okay. Now the center, of course, is going to be HK. So H in this case is 4. So 4. And then it's -5. Okay. Are there any questions? If there are no questions, then I would like to continue. So no questions. All right, let's continue with this then. So first, I'm just going to go over slope-intercept form, right? Slope-intercept form we've all learned about in Algebra 1, but it's good to refresh our memory because today we are going to be using slope-intercept form to model real-life situations. Okay, so slope-intercept form, you have a line, right? Okay, and we have an intercept. So what does this intercept pertain to? It's the y-intercept. This intercept means the y-intercept. And let me just give you the form. Y-intercept form is y is equal to mx plus v. I'm pretty sure you've already heard this, right? Y is equal to mx plus v. For b, let's dissect this a little bit. What is b? It is the y-intercept. Okay, and what is m? That is going to be the slope. So do we need to review slope? Fine, let's review slope then. Okay, review slope. It's not that hard. It's just going to be the delta y over delta x. So this, okay, not dx, that's derivative. Okay, delta y over delta x. And what this means is basically the change in y over the change in x is equal to the slope. Okay, so if we were to find the slope of this line, it'd be quite easy because with linear equations, that's exactly what they're for, right? Because they're constant. Their rate of change is constant, meaning that they're increasing at the same rate of change at any 2 points, right? So we find any 2 arbitrary points here, x1, y1, x2, y2. We take the change in the y's over the change in the x's, okay? And that's our slope, the rate of change, okay? And you get slope more when we learn into like the word problems, because a lot of times x is going to be something like time, and maybe y is something like miles. See, miles over time, right? That makes sense. That's the rate of change. Okay, now the y-intercept, so of course it's when it hits the y-axis here. Nothing much more to be explained with this one. All you need to do to graph this one is you need to go to the y-intercept, put a point there, and using the slope, find another point, then you graph. So we've done this before. I don't need to elaborate any further. Now, point slope form and standard form. So we might not have talked about standard form too much, and we probably won't talk about it too much because standard form right now it's kind of useless. Yeah, nobody really uses standard form much, and unless a question asks you deliberately to change into standard form. But point slope form is very important. Point slope form, I'd say, is the standard way to have an equation of a line. And this is because it's the easiest method. So let me show you what I mean. So point slope form is y minus y1 is equal to m times x minus x1. So as you can see, essentially what we're doing is we're deriving it from the definition of slope, which is y minus y1 over x minus x1, and just multiplying this to the other side gives us point slope form. So essentially, all we need is a slope and a point to have point slope form. And essentially, all we need is 2 points. We need 2 points, and just to find this equation of the line, which is very useful because you only need 2 points. And we'll be capitalizing on that later. So this one is also self-explanatory because it's just the definition of the slope. So if there's any confusion on these y's, X is compared to y1 and x1. So basically, when you're given a problem, x1 and y1 are real numbers. They are given to you. They're specific numbers, like 3, 5, or 4, 2. These are specific numbers, while x and y are arbitrary points. They're arbitrary points on this line. And basically, when you're given 2 points, you can find the slope, right? You can find the slope between 2 points. And since the slope is always constant, you just found the slope of the entire line. And you just plug 1 point in, whatever you choose, into that equation, then you can get the point slope form. And once you get the point slope form, you can convert it to the slope intercept form or to the standard form. Standard form, I'll just show you. Standard form, we don't really use that much, but I will be asking a question on it in the homework just to make sure you understand what it is. So that's basically just this. You're converting, well, standard form, it's called standard form because it looks nice, right? This pile of junk doesn't look that nice, but this looks very clean, right? This looks very clean. Ax plus by is equal to c. And one thing you can actually do with standard form that you can't really do that much with other forms is kind of useful too. So you can graph standard form equations using the intercepts. So you can find intercepts really fast with the standard form because if x is equal to 0, you can just find y, right? If x is equal to 0, cancel this out and you just find y. That's the y-intercept. If y is equal to 0, you cancel this out and find the x-intercept, right? So it's easy to find the intercepts in standard form, and that's part of the reason why we use it sometimes. Okay, so there's not much to go more in depth with that. I probably won't be going into depth with that because you've already learned the stuff. There's no need to elaborate too much. Okay. Now let's go on to vertical and horizontal lines. It's important to note that one of these is not a function. So vertical lines, it's like this, just the vertical line. Horizontal lines, of course, it's like this. It's important to note that horizontal lines are functions, whereas vertical lines are not. Okay, and this is because there's a couple reasons why. First of all, of course, the whole definition of a function is that for one x value, there cannot be more than a one y value. Through the vertical line test, we can see that the vertical line is not a function. Second of all, as you can see here, the m is changed in y over change in not d again. Okay, change in x. And from the vertical line, we can see that the change in y can be really anything, but the change in x is always 0. So we're dividing the change in y over 0, which is undefined. Therefore, the slope is undefined, everything is undefined, it's just not a function. And if you ever come across the question about like what's the slope of a vertical line, it's just undefined. There is no slope. But for horizontal lines, the slope is 0 because basically the change in y is 0, but there is change in x, so it's just still 0. And these are functions because of the vertical line test. It passes the vertical line test. Okay, now let's talk about some special relationships that you might not have learned. Okay, parallel lines. Okay, parallel lines have the same slope. Okay, and that is the symbol we use for parallel lines because parallel lines, they're the same distance apart forever. They'll never touch, right? That means they're increasing or decreasing at a same rate of change. That means they have the same slope. What about perpendicular lines like this? They create right angles. right? What about perpendicular lines? We use perpendicular lines. This is the symbol for perpendicular lines. They have, first of all, negative reciprocals. Their slope are negative reciprocals. So what do I mean by negative reciprocals? So that means their product is 1. Well, -1. Their product is -1. So if one line is 1/2, the other one is the reciprocal of that, which is 2, and then negative. It's -2. That's the slope. If one is -3, then the other one is 1/3. Like that. Those are negative reciprocals. You probably should have heard of that before, but I just wanted to refresh on that. Okay, so now on to the main topic for today, linear equations and models. So let me just go over. I'm just going to give you a couple of moments to try and do this. Right? We learned about lines, and I'm opposed to I'm opposed to the idea of just giving you guys everything, right? So I'm going to let you guys try this out first with the knowledge that we just learned or reviewed from linear equations to try to solve this problem. So let me give you A, which is write an equation that predicts number of students for a given year. B is to interpret the slope. And interpreting the slope is where a lot of students get mixed up. So I want you guys to have a try at that. And finally, I'll just do C when we walk through it. So right now, just do the simple first two steps. The first step is probably the most important. So I'm just going to give you a couple minutes to try this out on your own and see how it goes. Remember, you need to model this with an equation. And usually it's slope-intercept form equation. So make sure you know how to do that. All right, so we do have an answer from Evan. Very good. So let me just wait a little bit more so other students can try this out. All right, so I think we have a little bit more. Okay, so let's see how we did this. So William says 35,000 and then changed it to minus 70,900. Okay, so let's see. It all depends on how you look at it. So let's see here. Write an equation that predicts the number of students for a given year. So in 2000, the number of students at a large university was 35,000. Great. We already have a point. This is a point. In the year 2000, the number of students was 35,000. In the year 2010, it was 38,720. Great. We have 2 points now. And to write an equation that models this, we just need to find the slope and use point slope form. Okay, so let's find the slope. Basically, we just have to subtract 35,000 from 38,720 to equal to 3,720, and we have to divide that by 10. So the slope is going to be 372. And putting that into slope intercept form, let's just use this point, for example, the first point. And we get y minus this is equal to 372 times x minus 2,000. Okay. We get negative 709 35,000. Okay. Y is equal to 372x minus 709,000. So you might question, why is it minus such a large number? Well, we have to look at how we even got the equation. So what is x? Is the year, right? In the year 2000, we have 35,000 students. However, in the year 2010, we get 38,720. What about in the year 0? Of course, this university was not there at year 0, but that just shows the initial rate that there are negative 709,000 people in this university at year 0. But that doesn't make sense, really. But it still works. This equation is completely true. It works. Or you can do what I think someone did in the chat, and that was to basically put another equation, but this time instead of taking x as the literal year, like 2000s, we can actually assume x is the year after 2000. So, and instead we get points like 0 and 35,000, and then 10 of 38,720, because that's the years after 2000, and then you get an equation that makes more sense. But it all depends on how you look at it, and even if you have these different equations, you're still going to get the same answer. So now let's interpret the slope. So the slope, it's basically what is changing in y over what is changing in x, right? So what is changing in x? It is time, right? Time in years. What is changing in y? And that is 370 students attend every year. Well, 300 students go to attend every year. They start every year. And that is the slope. That is interpreting the slope. It is basically the y change, which is the dependent variable, because it's dependent on time, and it's over like the year, which is time, the independent variable, the change in y over change in x. Now, finally, let's do this last part here, which is the campus will need to expand. Needs to expand at 45,000 students. At 45,000 students, the enrollment needs to expand. So, at what year will the campus need to expand? Great. So now we just need to put this into like the equation, right? So we want to find x, and we know the number of students, right? 45,000. Great. We know the number of students, and we want to find time, which is x. And if you plug this into a calculator, divided by 302, you're going to get roughly 2026. You're going to have, the campus is going to need to expand when enrollment reaches 45,000 students, and that is in 2026. So that is how you solve problems like these. And here is another very similar problem, and I'm going to ask you guys to solve this. So first of all, read the problem, of course, and A is to find the pressure P. Second of all, Oh, I think I messed this up. This is not square foot. This is this not square inch? Okay, I don't know actually what pressure is, how we can actually measure pressure in this way. I know pressure is kind of measured in like atmospheres and pascals. I don't know what this is doing, but anyways, let's just put this as feet because these units need to match anyways. Okay, continue.
What is problem B? Oh, never mind.
All right, so I'm going to give you guys a couple of moments to do that problem. Then I'll come back and walk you through it. All right, so let's go over this. And there should be some pretty good answers for this. So, as we can see here, find the pressure P at depth of d feet. So we can say we know that the initial pressure is going to be 14.7 pounds per square inch at like the sea level, right? Sea level. And we know that's the initial. But what about the rate at which we descend, right? About 0.445 pounds for per every square foot that we descend into the ocean. Okay, so this is quite easy. The pressure is just going to be equal to 0.445 times d, which we can say at the depth, right, is plus the already initial pressure at 14.7. That is it. And the second one is quite easy as well. Is it safe up to 40 pounds per square foot? Okay. Well, we just set this as 40, right? 40 is equal to 0.445 d plus 14.7. And we get we solve for this, right? We solve for this. We get like 56.85 but we can't really we want to round this because in like real life examples like these we want to have a cleaner answer, right? So are we supposed to round up or down? In this case we always round down because if you round up that actually exceeds the 40 limit. We have to round down, right? Okay, so that is all for today, and I hope to see all of you next week. Wait a second. Next week? Hold on. What is next week? Next week is it is April the 2nd. So we actually will not be having class because it is spring break. That is our class of spring break. So I'll release announcements on the Google Classroom if you missed this announcement. Anyways, I hope you guys have a spring break, and I will not be seeing you next week. Then okay, I'll see you next week.
Thank you.
Bye. Thank you.
Bye, thank you.